All right, so we finished up our Thevenin Norton example here. Basically found our Thevenin and Norton equivalent circuits and went ahead and validated those circuits by putting our load resistor back into the circuit, testing to make sure that our load voltage and our load current were the same as they were in the original circuit, which was this circuit here. And we validated that the output voltage was indeed 1.28 volts and the load current was 1.28 milliamps. And now what I'm going to basically show you is a way that you can go through and determine the Thevenin or the Norton equivalent circuit from the other of the two. So if I have the Thevenin equivalent, here, let's just go ahead and Thevenin on this side, and then we'll put Norton on this side. Oops. Norton on this side. And if I have my Thevenin, so my Thevenin equivalent in this case was 6 volts over here for V Thevenin, and then for R Thevenin I had 3.667 kilo ohms. Okay. And I want to know what my Norton equivalent is. Well, I know my Norton equivalent is a current source in parallel with a resistor. And I also know that my resistor is the same for both Thevenin and Norton. So what I really just need is the Norton current, which we know from the example, we solved for that Norton current. Let's go back to the steps. Trying to find the Norton current, we used circuit methods to determine the short circuit current, which is the current through the load terminals when the terminals are shorted. So we did that here. We went and found our load terminals. It's these two terminals, and we shorted them together, right? And we went and measured the current, I short circuit, and that's exactly what we found here, 1.63 milliamps, and then that was our Norton current, 1.63 milliamps, okay? However, if I don't want to go through that whole process of shorting the load terminals, trying to do something circuitsy to find the current, I don't have to. If I have my Thevenin equivalent circuit already, I can actually go ahead and find I Norton using Ohm's law. So if we remember correctly, when we rearrange Ohm's law, we get that I is equal to V over R. Well, if I want I Norton, all I have to do is take V Thevenin over R Thevenin, and I get I Norton. So if I take 6 volts, divide by 3.667K, let me throw that in my calculator. I should get 1.63 milliamps because that's what I got in the previous case. Let's give it a shot. 6 divided by 3.667, 1.63. And so that is my Norton current. And so this is just, so basically if I have two of the three quantities, whether I have the Thevenin voltage and the Thevenin resistance, or I have the Norton current and the Norton resistance, I can go ahead and find the third quantity of these three just simply using Ohm's law. And so if I wanted to go the other way, let's say I already had my Norton equivalent circuit and I wanted to find, let's say I didn't know my Thevenin voltage and I'm actually wondering what that voltage is. Well, I can use the original form of Ohm's law, which is V is equal to I times R with my Norton current and my Norton resistance to get V Thevenin. So if I wanted to find V Thevenin, in this case, I would take my 1.63 milliamps, I would multiply it by 3.667K, and if I throw that in my calculator, I will get 6 volts, and that's exactly what I expect to get, okay? So just, this was the last little note here on Thevenin and Norton, that if you are asked to find both the Thevenin and the Norton equivalent and you're pressed for time on an exam, or even I may ask you to do them both, the full derivation of both of them on a homework, but if you're in a crunch for time or in any other case where you just don't feel like solving for the Norton current or the Thevenin voltage, or even if you don't want to find the resistance, you can use Ohm's law to find the resistance if you find the short circuit current and the open circuit voltage. Basically, if I take V over I, that will give me the resistance in both cases as well, because that is Ohm's law as well. All right, so we're done with Thevenin and Norton. We're going to move on to the next topic, which is source transformation, which is very heavily related to this slide here. So shouldn't be anything new, nothing too challenging, but we're going to go ahead and move on to that, and we are concluding Thevenin and Norton right here.